the bottom to the top and pole to pole. You probably could have swam in the Arctic Ocean right after the flood. It was so mild. So what is the significance of this? The warmer the water, the more the evaporation. At 30 degrees centigrade, you evaporate 7 times the amount of water into the atmosphere than you will at 0 degrees centigrade. 7 times. So, and this evaporation is especially strong at high and mid latitudes. That's where you want it, right next to the building ice sheets on the land. Also, the mechanism will persist, but it'll wane with time as the oceans cool off. It'll slow down. The ice age will slow down. And because of these mechanisms, you can time it to figure out, is it going to take 100,000 years like the evolutionists say, or is it going to be short? I will get into that soon. So here's kind of a schematic of what you'd expect. The dust and aerosols trapped in the stratosphere reflect some of the sunlight back to space, cooling the land. Here's the sunlight coming in right here, and the infrared radiation just passes right on through and cools the surface of the Earth, as well as the atmosphere. Also, we had a lot of volcanism during the Ice Age to replenish the dust and aerosols from the flood. J.K. Charlesworth, in a monstrous book called The Quaternary Era, a 1,500-page book on the Ice Age, says signs of Ice Age volcanicity and earth movements are visible in all parts of the world. There's a tremendous evidence that there's just a huge amount of volcanism. Now, the evolutionists know that volcanoes will cool because we've observed it today. When Mount Pinatubo blew, it cooled the Earth maybe a degree all over the Earth. But what they don't see is they stretch out their time for the Ice Age so long that these eruptions that they see in Ice Age deposits become insignificant. What we've done is telescope the time into a short time, so they become very, very significant. I'll get into that. From basic meteorology, you can guesstimate, that's just weather jargon, the storm tracks. Generally, because of the way that the poles are cooler and the equator is warmer, you have west to east flow. And the storm tracks, the main storm tracks, in meteorology, storm tracks are chaotic, but in general, you can have just some main storm tracks where storms will favor certain areas based on what's called the horizontal temperature differences. If it's a strong horizontal temperature difference, the jet stream will just generally be there, and it'll guide the storms parallel with the jet stream. And you can figure out it'll be cold up here in the ice, a little warmer down here in the land, so you'd have a main storm track south of the ice sheet going up in here in the ocean and losing its thermal difference, and so they'll kind of spread out and weaken. And you have another one along the east coast where you have cool land here and real warm ocean out in here, sort of like the northeaster track, right off like that. Anyway, this would be you can figure those out. You can also figure out where the greatest evaporation would be. They'd generally be just off the east coast of continents. And of course, in the Arctic Ocean, that was ice-free and warm. So here's where your greatest evaporation is. And this is where the ice occurred, just real close by. And the storm tracks would pick that up and dump it really fast on the land. So how fast was the Ice Age? That's the next question. Do we need 100,000 years for this? No, but here's my proof right here. That was so fast that he couldn't even get out of that outhouse. Seriously, this is the way I did it. I used what's called heat balance equations. You add up the heat inputs minus the heat outputs, and that's the change in temperature with time of the oceans. Since it has a time factor, you can figure out the time based on the amount of cooling. So, and I did this not only for the oceans, but for the atmosphere. And to make a long story short, these budget equations, there's no way to be precise. So what I did is use minimums and maximums because I wanted to bracket the time. And these minimums and maximums were rather outrageous. That's fine. I wanted the middle, which I felt was a better estimate. So I got ranges, a minimum of 297 years to 1,700 and some odd years to reach glacial maximum. The best estimate was about 500 years. Then you have to melt it. But first of all, you have to figure out how deep it is based on the amount of evaporation in the high latitudes and the amount of moisture coming from the low latitudes. And I used ranges again for these. I got these ranges right here for the northern hemisphere for best estimate about 2,330 feet. This is an average where I live in Montana. Alberta area wasn't very deep at all because a number of the little mountain ranges on the plains stuck up out of the ice, like the Sweetgrass Hills in north central Montana, the Cypress Hills in southeast Alberta. They stuck up out of the ice. But I think New England was hit heavily. The areas with the deepest ice sheet would be closest to the moisture source and closest to the storm tracks. And New England, southeast Canada would fit both of those. Well, Montana would be kind of far from moisture source and close to a storm track. So there was a lot of differences in the depth, but this is the average. For Antarctica, here's the figures for Antarctica. Since I've examined Antarctica, I think that this is low, but it's probably up more towards the maximum now. Anyway, now you have to melt it. Well, I use the energy balance over snow cover. This is the most scientific way you can calculate snow and ice melt. Generally, evolutionists just assume a slow melting with time in their models because they just kind of stretch it out. They don't hardly ever use an energy balance over a snow cover. And the way this works, most of the melting is by solar radiation that comes down and reflects in all kinds of directions. It melts the snow on the top, forming rivers on top of the ice. And a lot of times the water will percolate down and refreeze in here, but that's how it melts. Most of the melting is done by solar radiation. So plugging those in and using maximum and minimums again for albedos, which is the reflectivity of the ice and snow and things of this nature. I got a range of 40 to 100 years for the northern hemisphere, best estimate 70 years. Interior Canada being a little cooler, less solar radiation, about 200 years. So the total time for post-flood ice age is about 700 years. This is an example where we bring the flood back into Earth history. We don't need all that time. The flood solves 80% of our time challenges. 80% when we bring the flood back. Well, was there more than one ice age? This is a question people ask because they look in certain areas, they see evidence of a till sheet with some sand and then another till sheet, thinking that, there's two ice ages right here. Well, I believe in two ice ages. I believe there was an ice age before the flood, around the Garden of Eden, around the Garden of Eden, and this is it right here. Man and woman's relationship was created perfect at the time, and something happened, and it's not so perfect anymore, is it? Anyway, more seriously, I'm just going to summarize this. In an article in Geology, 1994, Young et al. State, glacial reconstructions commonly assume multiple glaciation hypothesis in all areas that contain a till cover. The multiple ice age